In this video, we are going to find the domain and range of a radical function. It is useful to remember that the graph of your basic radical function works like this. Say if I had y equals the square root of x. That function would look something like this, starting here at the origin. And of course the domain, which is x values, would be from 0 to infinity. You know what, let me put a bracket on that, because it can actually be 0, so that's cool. The range would also be 0 to infinity, because it's the y values, but it starts here at 0 and goes up. So it's just a matter of shifting this thing around. When we look at these changes, the main ones that we want to be aware of are the +1 right here and the +3 on the outside. This +3 on the outside is going to move the graph up 3 compared to the parent function that I just showed you. Alright, this this +1 right here is going to actually move the graph left 1 compared to the parent function. Now this 3 on the inside is actually going to be a vertical compression by a factor of 3. A horizontal compression. So that's going to just make the graph, shorter looking, but you can, in terms of the domain and range, you can ignore that. So just pay attention to the left and the up part. Alright, because when you're talking about a graph that goes forever, I'm talking about a horizontal compression and a vertical compression. It's really hard to see, and it doesn't affect the domain and range. Okay, so if I go left 1 and up 3 with this thing, then what am I talking about? If I went left 1, up 3, 1, 2, 3. So I'd be talking about a graph that is here and then does its thing from there. Okay, so that means the domain is going to be the x values from, if it goes from -1 to infinity. Then the range, which is the y values, well, it starts off here at a y value of 3. So it's going to go from 3, and then it goes on up forever, y values, so 3 to infinity. So this would be the domain and the range. Alright, just for some visual reinforcement, let's glance at this on the graphing calculator. If I look at the parent function, square root of x, alright, so there's that graph I was talking about. Let's see what happens when we talk about, let me just do square root of x plus 1 and then plus 3. Okay, so let's do the square root of, square root of, alright, I want x plus 1, and then I want, on the outside, plus 3. Okay, so you can see, just like I thought, it's left 1 and up 3, just like we predicted. Okay, now I was claiming that putting a 3 in front of here, the real equation has a 3 here. I was claiming that that wouldn't really change the domain and range. So let's see. Alright, I've turned this one off, so when I hit graph, I will now be graphing this one with a 3 here. Let's see what happens. So there's that parent function, and sure enough, so it's still here at -1, 3. And let's go ahead and graph them both at once. and see if there's any difference, see what difference we can see. Alright, so you can see they both start from -1 comma 3 right here. It's just that the one with the 3 on it goes up faster, but that doesn't change the domain or the range because it's infinite.